The morning rush at a metropolitan subway station moves with practiced efficiency. Commuters approach the fare gates in a steady stream, slowing only slightly as they reach the readers mounted at waist height. A brief tap of a card or phone triggers a soft tone and a green arrow, and the gate panels slide open. There is no exchange of cash, no printed tickets changing hands, and no visible verification beyond the momentary signal. The system processes thousands of entries within minutes, maintaining the pace of the crowd rather than interrupting it. In this setting, contactless payment is not a convenience feature. It is an operational necessity. Public transit systems must move large volumes of people through constrained entry points while minimizing delays. Every additional second spent purchasing or validating a fare can accumulate into congestion, missed trains, and platform overcrowding. The adoption of contactless payment technologies in transit environments reflects an institutional need for speed, predictability, and reduced friction at scale. Transit authorities were among the earliest large institutions to implement tap-based fare systems because their operational constraints made traditional payment methods inefficient. Paper tickets required printing, distribution, and inspection. Magnetic stripe cards reduced some friction, but still required physical contact and were prone to wear. Contactless smart cards and later mobile wallets allowed gates to verify fares in fractions of a second without mechanical insertion or swiping. The technology aligned with the institutional goal of maintaining flow. The widespread adoption of contactless payment did not occur through a single innovation, but through the convergence of technical standards and institutional coordination. Early smart card systems used radio frequency identification, RFID, to communicate between card and reader. Over time, international standards such as ISOAC 12443 defined how contactless cards and terminals exchange data securely at short range. These standards enabled different manufacturers to produce compatible cards, readers, and chips, reducing vendor lock-in and allowing systems to scale across regions. Payment networks and financial institutions later integrated these standards into bank-issued cards, enabling the same tap interaction used in transit to function at retail terminals. This interoperability was not accidental. It required coordination among card networks, terminal manufacturers, banks, and regulators to ensure that a contactless transaction met security, authentication, and settlement requirements. The familiar tap gesture became stable only because the underlying systems agreed on how data would be transmitted, encrypted, and authorized. Standardization also shaped user expectations. A single gesture bringing a card or phone close to a reader produced consistent feedback. A tone, a light, a confirmation message. Whether entering a subway station, boarding a bus, or paying at a cafe, the interaction followed a shared pattern. This consistency reduced cognitive load. Individuals did not need to learn a new process for each location. The standardized interface allowed the behavior to transfer across contexts. Repeated use in high-frequency environments reinforced this stability. Commuters tapping through fare gates twice daily developed familiarity with the gesture, the timing, and the feedback signals. Retail environments benefited from this learned behavior. When customers encountered contactless terminals in stores, the interaction felt already known. Adoption accelerated not solely because the technology was available, but because repeated exposure in institutional settings normalized the behavior. Security protocols played a critical role in enabling institutional trust. Contactless payments rely on encrypted communication and tokenization to prevent interception and misuse of card data. Standards defined how sensitive information would be replaced with temporary tokens during transmission, ensuring that even if data were captured, it would be unusable. Financial regulators and payment networks established liability rules and fraud monitoring systems that reassured merchants and transit authorities that adopting contactless systems would not increase risk. This trust allowed institutions to redesign their processes around the technology. Transit agencies reduced the need for staffed ticket booths. Retailers shortened checkout times and reconfigured queue layouts. Event venues replaced paper tickets with tap-enabled entry systems. Each adaptation reinforced the presence of contactless infrastructure, expanding the network of places where the gesture functioned reliably. The role of mobile devices further accelerated adoption by consolidating multiple credentials into a single interface. Smartphones and wearable devices incorporated near-field communication, NFC chips that emulated contactless cards while adding biometric authentication. This integration aligned with institutional requirements for both convenience and security. A transit gate could process a phone tap as quickly as a card, while the device's authentication methods provided an additional layer of verification for financial transactions. The stability of contactless payment systems also depends on their invisibility within broader infrastructure. Readers are integrated into turnstiles, payment terminals, and access control systems. Software updates occur without altering the user interaction. Settlement processes between banks and merchants operate in the background. From the user's perspective, the system appears simple from an institutional perspective. It is sustained by a network of standards, agreements, and maintenance protocols. Over time, the presence of contactless payment has reshaped expectations about transaction, speed, and physical interaction. In environments where tapping is available, cash handling and signature verification appear slow and exceptional. Institutions respond by prioritizing tap-enabled terminals and encouraging their use, not through mandates, but through design choices that make contactless the most efficient option. This gradual preference reinforces adoption without requiring explicit enforcement. The persistence of contactless payment today reflects the alignment between institutional needs and standardized technology. Systems designed for rapid throughput, reduced maintenance, and interoperable security continue to rely on the same tap-based interaction introduced in transit networks decades ago. As new devices and payment forms emerge, they integrate into the existing standards rather than replacing them, preserving the familiar gesture while extending its reach. In crowded stations, retail counters, and entry gates, the brief moment when a device meets a reader remains largely unchanged. The tone sounds, the indicator, lights, and the flow of movement continues uninterrupted. Through standardization, coordination, and repeated institutional use, contactless payment has become a stable component of everyday systems, functioning not as a novel technology, but as an embedded part of how large organizations manage movement, access, and exchange.